Hey guys, welcome back. We got number 9. You have 75 milliliters of sodium fluoride is mixed with 25 milliliters, 0.15 molar strontium nitrate. Calculate the concentrations and find the final solution of all these guys. And it gives you a KF, or KFSP, excuse me. Okay, so what's going on here? We have We have 75 milliliters, 0.060 molar. And this is our NaF coming in. And we have 25 milliliters, 0.15 molar, SRNO32 coming in to give us 100 milliliters. So there's a dilution right away. All right, there's a dilution. Okay, but there's also a reaction as well. Strontium fluoride. Oh dear, what's going on? There's a lot going on here. Okay, and so first, let's look at the reaction. The reaction is what? SR 2 plus 2 fluorides make SRF2 solid. All right, so we're going to assume, here's what I'm going to do. I'm going to assume that everything reacts, and then we're going to find out how much doesn't react, if that makes sense. All right, so let's just do the concentrations. So we have M1V1 equals M2V2. So we have 0.060 molar. We have 75 milliliters equals M2 times 100 milliliters. So what do we get? 0.06 times 75 divided 100. We get 0.045. 0.045 molar NaF. Same thing here. M1V1 equals M2V2. So we have 0.15 molar, 25 milliliters equals M2 times 100. So 0.15 times 25 divided 100. Yep. 0.0375 molar SRNO32. All right. So continuing on. All right, going back, we would have strontium. We have 0.0375 molar. Fluoride, we have 0.045 molar. Okay, that's great. Who's limiting reactant? Well, fluoride is, right? Divide that by, right, if you remember from Chem 1, divide by the coefficient, 0.045 divided by 2 is smaller than 0.0375. So it means fluoride would be the limiting reactant. And so it would be minus what? Half of 0.045 and minus 0.045 and plus 1/2 of 0.045. All right, and so 0.0375 minus half of 0.045, I get 0.015. 0.015 molar, nothing, and 0.015, which it's a solid, so we really don't care about this. All right, So now we have our concentrations. Now we're going to do KSP. So we'd have our strontium fluoride, solid. Now with this in our ice table, we got a little bit different this time. All right, initially, we're going to have 0.015 molar. Nothing. Plus x plus 2x. So we would have 0.015 plus x and 2x. Now, with this, KSP is 4.3 times 10 to the negative 9, which would be equal to strontium concentration and fluoride squared. Well, 4.3 times 10 to the negative 9 equals 0.015 minus this plus x and 2x squared. We're going to approximate this change to 0 because we're way, way different in size. So that means we have 4.3 times 10 to the negative 9th equals 0.015 times 2x squared, which is 4x squared. All right, so how do we do this? 4.3 times 10 to the negative 9 divide by 0.015. I get 2.87 times 10 to the negative 7 equals 4x squared. Divide by 4, and then take the square root. I get 2.7 times 10 to the negative 4th. Now, X is the concentration of SRF2, right? It's not even the concentration of strontium because strontium is bigger than that. Fluoride is 2x, so that's going to give me 5.4 times 10 to the negative 4 molar for fluoride. So that's fluoride. Strontium is what? 0.015 molar, right? That's what we got because we're saying it's the common ion, and there it is. Sodium we have as 0.045 molar because that didn't change here. That's right here. All right. Nitrate is double this. So the concentration of nitrate equals 2 times 0.0375, which I'm getting at 0.075 molar. All right. So that's all 4 ions, which is a lot. That was a lot. Hopefully that works for you. If you have any questions, reach out. Otherwise, we'll see you in the next one.